there are some people who tell me they find kind of complex to understand, that they find kind of hard to understand what's the actual potential. So I'm gonna be here explaining, I'm gonna be here making a quick summarize, just to make sure that everybody is gonna be able to comprehend everything that's being told there. So, the communication of the neurons divided into two different parts, which the electrical one is going to stimulate the neurons signal, and the chemical one that we call the neurotransmitters, the synaptic transmission, that the presynaptic neurons going to release the neurotransmitters, it's going to bound to the postsynaptic neuron receptors. So the actual potential is this electrical part, and what we're going to be talking about today. And first thing that they have to know is that outside the neuron there is a phenomenon they call the bomb of sodium potassium. That assures that it's going to be sodium outside the neuron and potassium inside of it, and they're both positive molecules, but there's more sodium outside than potassium inside. So we say that outside of the neuron it's more positive, hence inside it's kind of more negative. And what we have to do in order to stimulate the neuron to make this job, to send the signal, is to make it more positive. It has like this. The neurons, the presynaptic neurons get release neurotransmitters, and they're going to bound to the postsynaptic neurons. We're going to see this process on the synaptic transmission class, and it's going to stimulate to open a sodium gate. Open a sodium gate, sodium that is outside the neuron is going to start going inside. It's going to make it more positive. So the neuron that was resting was on minus 7 millivolts, it's going to go to minus 55. Once it hits minus 55, it happens a threshold, which is a very important phenomenon, that all the sodium gates spread throughout the neuron, they get opened, so a lot of sodium that was outside is going to go inside, hence it's going to make it way more positive. So it's going to go from minus 55 to positive 40. Once it hits positive 40, you cannot just tell the neuron to fire. You're going to have to make it rest a little bit. That's what we call the repolarization. That's the second part of the actual potential, in which the sodium gates, they get closed, so sodium is not going to be able to go inside anymore, and the potassium gates, it's going to open. The potassium was outside of the cell, so the potassium that was outside, it's positive, it's going to get out, it's going to make it very negative. So it's going to go from positive 40, that was a lot, that was very positive, and it's going to go from minus 90, which is going to get even more negative than when it started. So you're not going to you're not going to be able to stimulate the neuron anymore for a while. You're going to have to give it a rest. And that's pretty much the actual potential. And as I said in the video, it's sort of represented by the graphic, which is what I just said. It's going to sort on minus 70. The neuron, the neurotransmitters is going to bounce to the neuron. Then it's going to open the sodium gate. It's going to make it more positive. It's going to go to minus 55. The threshold is going to happen. All the sodium gates are going to open, so it's going to get way more positive. It's going to go to positive 40. Then it's going to happen that's the first part that we call the depolarization. Then it happens the repolarization, which is the all sodium gates closing, and the potassium gates, the potassium that was inside, it's going to close, it's going to open, so the potassium is going to go outside. It's going to make it even more negative than when it started. It's going to get the neuron to minus 90 millivolts. That's the actual potential. Thanks for watching.